Okay, welcome back. We're now going to talk about the important considerations for risk assessment. One of the fundamental considerations is whether you're dealing with the chemical in the form of a gas or a liquid or a solid. Is it in the form of a fine dust, for example? What is the behaviour of that chemical in the air? How's it likely to be presenting itself to the worker? Okay? It's one thing to swallow a chemical, it's another thing to be breathing in dust or spray painting. Okay? Do you need to understand how the chemical is presenting itself to the body? Now, depending on how the chemical is presenting itself to the body, there may be dominant routes of exposure. For example, if it's airborne, it's almost certainly going to be, at least a significant component of the risk is associated with inhalation. But then again, some chemicals just absorb through the skin more easily than others. They're not volatile, they're not becoming airborne easily, and they are absorbed through the skin. Some people also ingest chemicals if they're smoking or eating in the workplace, and some other scenarios you may get injection or penetration of the skin through the work that's required. And I can't stress this enough, you need to understand how the exposure is occurring, because if you understand how the exposure is occurring, you can intervene to prevent the exposure or minimise the exposure. If you don't know how the exposure is occurring, how the hell are you going to control the risk? Because exposure is the currency of risk. Only possible to get high risk with high exposure, or sufficient exposure. Now that depends on the dose-response relationship, of course, and we mentioned that briefly with Paracelsus and so on. Now, how do we know what's going on with exposure? We can sort of evaluate it by doing these walkthrough inspections, and it's probably the best way of doing it. If you use your sense of smell or observation of dust on surfaces, it's only going to tell you part of the story. What's the problem with just using a sense of smell?
Might not relate to the dose. Something just have an odour to it.
Some things are quite smelly, like... Should I open this? It's a hazard. I haven't even opened it and I can smell it already. You want to just take a small whiff?
You smell it because you read it before you smell it. It's got poison written on the
Let's
side.
put notes. It's warning. It's toxic. Richard will smell it. Smells like mothballs, doesn't it?
Yeah, it's a mothball.
It's all right.
It's safe to smell.
Put it in cupboards.
Okay, now you could smell it, but is that a high enough concentration to represent a health risk? Maybe, maybe not. Then there's some things that we can't smell very well, or at all, like carbon monoxide, for example. And even if we could smell it, we can get habituated to it. Now, I've seen workers who use naphthalene, and they don't notice it after a while. You walk in the room and you think, oh, how can they put up with that? Same with people who are using nail chemicals, dry cleaners and stuff like that.
Like hydrogen sulfide is a good one because you actually knocks out your smell after a certain amount of time.
So you can get what's called olfactory fatigue, and if you happen to be anosmic, in other words, you haven't got any real sense of smell anyway, it's not going to help. Okay, and there are some people who are super sensitive to smells and will pick up just about everything. So it's not a very good tool. That said, I swear by it. I think sense of smell is fantastic. For me, I don't believe too much about chemical problems unless I can actually experience it myself with a smell. Okay? That might seem a little bit, masochistic. This guy wants to expose himself to these chemicals. But the reality is that I can, because of my experience with monitoring chemical concentrations, I can relate the smell that I've experienced to a concentration. So I can link the two together. Hygienists can do that because they've got the equipment to do it. Everyone else really doesn't quite understand, what's that concentration actually mean. So, sense of smell is not recommended, but it's not, in the right sort of environment, it can be quite helpful. It can certainly alert you to a problem. And particularly if you're wearing respiratory protection, you suddenly get a sense of smell, it means that the respirator's not working properly. The other thing is sight. Okay, now, I've mentioned that you can see dust on surfaces and so on. What about dust in the air? Does that tell you what the concentration is? If you can see dusty environments, does that tell you there's a problem or not? Don't have a consensus on this one.
Yes and no.
You're on the fence. What do you mean yes and no?
Oh, well, it's a problem because there's dust, but it's the type of dust that causes the issue is the dust that you can't see.
The Electrolux factory, the woman there turned around and said, yes, there is a lot of dust there, but it's not harmful dust.
What is he really meaning? That this doesn't exceed the exposure standard, or?
It does.
Okay. Well, now there's no hard and fast rules on this one, but if you can see dust in the air, it may be a problem. Okay. If you can't see dust in the air, it doesn't mean there's not a problem, because a lot of examples of toxic dust are fine dust or nano-sized particles or something like that, which may not be visible under normal lighting conditions. And the good example of that was crystalline silica and things like asbestos and so on. So yes, if you can see it, it's probably a problem. Under normal lighting conditions, it's probably a problem. Now, just be aware that if you're using smell or you're using your senses, you can end up with what we call psychosomatic responses, where you associate the smell with something awful, or you can have group responses where somebody says, "Can you smell that?" and suddenly everyone can smell it, even if it's not there. And the only way you're going to get rid of that situation is by removing the chemical or visible contamination completely. So it's sort of a cumulative issue, even though the actual concentration was always the same.
There may be chances of smell addiction.
Smell
It can be, people can get addicted to the smell. Yeah.
An association, you mean? It's a conditioning. Yeah.
We can suppress the psychosomatic responses, and they can get they could have addiction to that smell. Like, for example, people have benzene, petroleum, smell addiction. They have acid addiction, and there are many.
I must admit, I haven't. A good point. I haven't come across that in a workforce scenario, but I guess it might be.
And some unpleasant smells are not so unpleasant if they're familiar.
I used to be a plumber. I used to have to do sewer trades. Get used to it. But there's certain things that you never get used to, and it's called grease traps. Because they're worse than sewage.
Yeah.
But you do get used to it, you're right. But nowadays, if I go near it, I can't stand it. Because I've been out of that for probably about 5 years.
Okay. One thing just to be aware of, that there are some linkages between our olfactory system and the brain, and some chemicals can be taken up through the olfactory system into the brain. Some nanoparticles that can be a route of exposure as well. the sense of smell was thought to be related to neurological problems and maybe an early indication of neurodegenerative issues. And I'm not saying Parkinson's disease or motor neurone disease or something like that specifically, but there's an increasing amount of evidence to suggest that if you happen to lose your sense of smell, you might be more likely to get those conditions afterwards. Okay, the good old incident reports and the first aid reports, you can do a lot by just looking at what the history of those reports might be in the workplace. If people have been getting breathing difficulties or skin irritation or something like that, you can understand whether or not that's a problem, just on the history of the workplace. And of course we can do exposure monitoring, which is the interesting bit in many ways of occupational hygiene, using all types of detection systems for monitoring chemical contaminants. Okay, so if you are going to be using a detection system, you need to compare the value with an exposure standard. So here we have a simple detection system. Remember that on that video I showed you the what we call a short-term detector tube, and this is basically a chemistry set in a tube. So inside these tubes we have a chemical that reacts with the chemical of interest. It may cause a colour change, and the length of the colour change on a scale tells you what the concentration is. So I'm going to be demonstrating this with a example of a chemical in the atmosphere which isn't toxic. That's broken off. The acid's got to it. It's corroded out completely, so I'm not going to be able to do that, unfortunately, but I'm going to do something different, which is break open both ends of the glass tube so that we then suck air through this tube, and there's an arrow indicating which way this goes to the pump. So what this is a bellows pump. And what I really should have done to start off with is to make sure there's no leaks in the pump. So here we go. This is a sealed glass tube, and I'm going to just insert it in there, and I'm going to squeeze it. And you'll notice how that stays squeezed. Okay, because there's a little bit of a leak there, but the air is supposed to go through that tube. This is about 100 mils. So I'm going to get somebody to squeeze it. Now you squeeze it, push it in all the way, and then let it expand all the way. So have a look at on the scale what happens. So give it a squeeze and let it out again. Just let it out. And have a look on what's happening at the top. You notice how that's changed colour? It's gone from light brown, sandy brown to green on the top. Okay, so if you squeeze it, if somebody wants to squeeze it again, so give it a good hard squeeze and then just let it go out. Let it out. So it's 100 mils going through each time, and you can look at the documentation that comes with the tube, and you can read off what that is. So this is what we call a short-term detector tube. So if you have the right tube, you can estimate what the air concentration of the contaminant is. In this particular case, it's water, so we're going to have a relatively high concentration of water later.
10 grams away. 10 mg.
Okay. Now we've got tubes for all sorts of different things. We've got one for, take my word for it, things like chlorine, hydrogen cyanide, sulfur dioxide, ammonia, and so on. So you can do a quick check if you wanted to using those detector tubes. The system is a few $100s for the pump, and then the tubes are about $15 each.
Is it an accurate reading?
Plus or minus 25%. I mean, there's some other chemicals that can interact or interfere with that, so it's not perfect. But as a quick check of what the concentration is, you can use that system, short-term detector tube. The alternative is to have what we call a direct reading instrument that measures the concentration and reads it off on a scale.
Right. That's right.
That's a Draeger one. This is carbon monoxide. Now, if I'm measuring, if that was, say, chlorine, or if I was measuring carbon monoxide using the detector tube or with this direct reading instrument, I'd need to compare the number with the exposure standard to make sense of it, wouldn't I? I'd be saying, well, if that's 2 parts per billion, what's the exposure standard? Is that 2, or is that 200, or is that 0.2? How do I interpret the number? So that's what the exposure standards are all about. And as I said right at the very start, this has only been around for 100 years or so. It's not like we've had a long history of dose-response relationships. Now, the documentation associated with some of these exposure standards is good. Some of it's pretty weak. And generally these are just guidelines. They're not fine lines between safe and dangerous concentrations. Some workers can tolerate concentrations above the exposure standards. Some workers can't tolerate concentrations below, half or a quarter of the exposure standard. There are always some people who are hypersusceptible, and the basis of the exposure standard is that it protects nearly all workers. Nearly all meaning nearly all normal workers, but not everybody. Now, you might be susceptible because you've been given medication which interacts with that chemical in the atmosphere, in the sense that it interacts with the effect on the body. You might be susceptible because you're genetically not able to metabolize that chemical, for example. You might be susceptible because you're pregnant. You might be susceptible because you happen to be doing some other work at home with another chemical and it's not in the workplace. So if you do the walkthrough, or you've got some information about symptoms and so on, that's an indication that there might be more to be done. But if the exposures are well below the exposure standard, I'm saying, well, let's say, for example, you measure 1 and the exposure standard is 100, well, it's pretty unlikely that there will be people experiencing problems.
So with people being more susceptible, is it a bit of a myth that if people's tolerances are higher if they've had lower levels of exposure, like often the case with people who are allergic to things, they've got a minimal exposure, then they've got a less chance of being allergic to things. So if you've got someone that's lived in a very clean environment away from lots of chemicals, and then all of a sudden they're exposed, will they be more susceptible to react?
Probably, yeah. I mean, the body does respond in a number of ways. So if you've never been exposed and suddenly you are exposed, the body's not recognising it.
So would you really at the time workers worked in that field, but when you're apprentice, they might be more susceptible?
Young new workers, yes, probably. People who've got an allergy, they've got an allergy to something, like if people have got asthma, for example, and they're exposed in a dusty environment, they're going to experience it. People who've never been exposed may be more susceptible, more likely to be susceptible. You know, it depends on the chemical. It depends on what the actual mechanisms are for the effects.
We've got a refrigeration plant where I work, and every now and then the ammonia vent, and only vents a very, very small amount, but there's certain people on the site who will be nearly knocked over by it, and there's other people that can basically stand there while it's happening.
Some people enjoy it too.
Yeah, the refrigeration guys, doesn't bother them. They like the work. It's the noise.
Clears the sinuses. Okay. Anyway, these are derived values based on animal experiments and human experience and so on. The important thing is that the employer needs to ensure that the air concentrations of the chemicals don't exceed the exposure standard. Right now, majority of these exposure standards are based on what we call personal monitoring in the breathing zone. Okay, and the majority of them are 8-hour averages. So in an 8-hour day, which some people work, 8-hour day. Some chemicals are toxic because the effects are irritation or narcosis or asphyxiation, and you could be killed in a matter of minutes or be incapacitated in a matter of 5 minutes with some chemicals. So they do have, apart from the longer term average, they have a short term exposure limit measured over 15 minutes or a peak limitation for some chemicals which are just extremely toxic or irritating and cause short-term health problems. So you'll see 3 kinds of exposure standards. The 8-hour average, you may also see a short-term exposure limit or a peak limit. Now, if you see a peak limit, you can't exceed that at any time during the day. The idea is that you prevent sort of a ceiling, if you like. You can't exceed that value at any time during the day. If you do, then you've exceeded the standard. Right? It's no longer about averages, it's just the fact that you've exceeded it. Now, you can do that using one of those systems. How long does it take to do a measurement? It only takes about a few minutes to do a measurement. I'm not asking you to do it, but I'm saying if you wanted to take a reading with this sort of thing, you could do it in a few minutes. Now, let's imagine somebody's got a job in a paint factory where they're doing their normal work and there's a background level of solvents. And every now and then they have to get into the bottom of a tank or stick their head into a tank and do something. Now, that short period of time they stick their head in the tank, they could have quite high exposures, and so you can use that to measure what that is next to their head whilst they're doing that job. So that's an example. This is what we call a grab sample. Okay, just a grab sample for a short period of time. You can get longer term tubes and a whole range of other devices. In fact, there's a nice little bedtime reading book on air sampling instruments, which is about 500, 600 pages. I'll just pass that around for information. The point here, and this is from an occupational professional's perspective, point here is that these are guidelines. Even though they're in legislation, they're actually just guidelines. Second point is, just because the number's high, it doesn't mean it's extremely toxic. And just because the number's low, it doesn't mean it's not toxic. So the actual numbers themselves are based on different criteria. It's not about killing people, it's about symptoms or limitation of work capacity or long-term health effects like cancer and so on. Individuals vary in response to chemical exposure. These numbers are not about skin absorption, they're about inhalation. So if you get a chemical that can be absorbed through the skin as well as by inhalation, there is a notation there in the standard that says skin, which means that you can have in fact, you can have your majority of exposure through the skin rather than by inhalation. I'll just illustrate that with a situation where somebody is protecting their respiratory system by wearing a mask, and they're thinking they're not getting exposed by wearing a mask. They think that's all they need to worry about, but they don't protect their body, they don't protect their hands. So if the chemical's got a skin notation, they need to protect both, okay? Because they could fool themselves into thinking that I'm protected, but in fact they're getting it through the skin, and that can occur cumulatively. We've got plenty of examples of chemicals that are absorbed into what we call the epidermis, into the fatty sort of part of the skin layer, and then it sits there like a reservoir, and then over a period of 24 hours or 48 hours it's gradually getting into the blood. Okay, so your skin becomes a kind of a sponge, and you wash the surface and you think, oh, that's great, I've got it all off, but it hasn't, it's just gone into that part of the skin. And so there could potentially be problems. These exposure standards don't account for mixtures. There may be some scenarios where some combinations of chemicals work on the same part of the body, and you've got some rationale for adding up, if you like, the numbers. Most of them are based on limited information for humans, often based on animal experiments requiring extrapolation or epidemiological studies where there's some reliance on historical data. These exposure standards protect the majority of workers over a working lifetime, but not all workers. If they're working extended shifts, say 12 hours or 14 hours, there's an adjustment that should be made for some chemicals. Some exposure standards require what we call size selective sampling, where we're only interested in the fine dust, for example, rather than all the dust. And as I mentioned, some have a skin notation which indicates that an appreciable amount of the exposure can occur through the skin. Okay, so if we were interested in that issue, we could do things like skin wiping, right, to get some idea of how much is on the surface of the skin. We could also measure concentrations inside respirators, concentrations inside gloves, inside overalls. If you suspect a chemical is going through the skin, you can get some idea of the extent of that problem by attaching sensors, if you like, which might be colour change sensors, on certain parts of the body where you suspect there could be a problem. They've even done things like apply a tracer to the chemical, and the tracer changes colour, or is very colourful, or is visible under black lights or something like that. So when a person gets exposed on the skin, you can actually see where the problem is, and it may be around the neck. It's a very common situation where workers are getting exposure around the neck, obviously on the hands. It's a very significant route of exposure, but also on the feet and on the shins where there's splashes, or there's normal shoes worn, not protective shoes, but normal shoes, and they get an accumulation of chemical into the leather or something like that. So you've got to be mindful of the potential. Now, how do you do that in a walkthrough situation? You really have to look at the work practices, see where the splashing might be, or whether there's any wet areas, whether they've got any indication or potential indication of contamination around the neck. If all else fails, you can do biological monitoring, looking for contamination in the blood or the urine or the breath. Now we've got a narrated lecture on biological monitoring, and I may address this a little bit next week. But biological monitoring complements environmental monitoring. If you don't know if your protective clothing is working, you can do biological monitoring. If you think there may be some non-occupational exposure, you can do biological monitoring in some cases. If you're concerned about personal hygiene or something like that, you can often do biological monitoring. But what advantage of air sampling there is, or environmental sampling, is that it tells you where the problem is, because it's on that surface, or it's in the air, or at that time, for that task, and so on. Whereas biological monitoring often is integrated, and you get a value at the end of the day, but you don't know what it means. Was it occurring at that time? The other thing about environmental monitoring is you can attach an alarm or a flashing light, an audible alarm, so that if the concentration exceeds a certain value, the alarm goes off. Right, if you had to rely on biological monitoring, the person would be dead. Okay, so there's advantages and disadvantages.
Very effective. He's dead.
You can do your post-mortem afterwards.
It's a defined endpoint, isn't it?
Okay, let's talk about the tasks, because some tasks or activities are intrinsically more dangerous than others. Going into a confined space. Clearly, whatever problem you've got with chemicals in the environment are going to be magnified in a confined space. Quite apart from the higher risk of explosion, you've got potentially much higher concentrations. You may have some personal protective equipment that is actually not working properly and becomes the hazard in a confined space. Generally speaking, where you have limitations on the work and high temperatures or confined spaces, you can expect problems. Certain processes are intrinsically more hazardous. So spraying pesticide is more dangerous than just brushing on or drips and drabs. Having fine powders is more dangerous than using pellets. So you'll need to not only consider the chemical, but in what process is that chemical being used. Now, beyond that, there's the workplace environment itself. It might be such that there are high temperatures in the work area, or there's high humidity, or there's sunlight coming in. Might be in an environment where there's sources of ignition or incompatible chemicals nearby. So this is like the worker and the workplace. Remember I mentioned that before? So what is it about the work that they do? What is it about the worker, and what is it about the general environment that they're in that could lead to the risks? Occupational hygienists generally don't concern themselves with genetic problems or drugs or, whether they're alcoholics or that sort of thing. They don't ask those kind of questions, although maybe they should. Because they can interact. And certainly smoking with any airborne contaminant is a problem. Alcohol consumption with a lot of chemicals which are metabolised in certain ways can be a problem. Genetic factors can be a problem. Endemic infectious disease can be a problem. If you're in a tropical environment and there's background levels of fever, dengue fever or malaria or something like that, that can also influence whether workers will be at risk because their immune system's been limited. Risk communication. This whole business of consultation is quite important for chemicals because most workers don't understand the chemical problems. They don't really understand the exposure routes. They don't really understand control measures. So you need to make sure that they recognise the hazard, they know what the symptoms of overexposure are, how they can control that exposure, and what training or understanding they need for safety data sheets and so on. You can have a manager who says, look, we're going to do some air sampling in the workplace, and the consultant comes in, does the monitoring, and then is not allowed to communicate those results to the workers because the information belongs to the manager. Now, that's clearly not acceptable. You know, as a professional, the primary reason for doing any of this is to protect the workers, not the managers. So you've got to be careful about ensuring that there is ultimately translation down to that level. I won't talk about legislation and standards and that sort of thing. Control measures we've already discussed, elimination, substitution and so on. Personal protective equipment, we're going to deal with that next week. Whatever you do in terms of control, you need to follow up to see it's effective, whether it's ventilation, whether it's some personal protective equipment and so on. All right, so let me just stop that one. And for the online people leaving it there,